Good morning and welcome to what seems like week 30 of the COVID quarantine. For those of you joining me, we are learning about some geometry today. And if you think about the last couple of months or so, we've been talking about triangles. Most specifically, we've been talking about right triangles. And this week, we're going to shift gears a little bit and talk about another important shape in geometry called the circle. Circles are things you guys have dealt with in previous math classes, so some of the stuff we're going to cover over the next couple of weeks should be some review for you. Other things should be fairly new. So the purpose of the next couple of weeks here are to reinforce some major ideas that involve circles, but also to introduce you to some new information that you may not have seen previously. So what we're going to start with this week is working with angles and how they relate to what we call the arcs of circles. So we start with a couple of definitions, and if you're following along with the guided notes, these would be the first two pictures that you're going to be working with on those guided notes. So two vocabulary terms: central angle, an angle whose vertex is at the center of the circle. So when you're looking at your angle, that vertex is going to be right at the center of the circle. So in the picture down below here, you can see that there's this angle BCA, that is a central angle. Okay, so angle BCA there is that central angle. So vertex right at the center, point C here. Another thing you're going to need to know for this section here is an arc. So an arc is an unbroken part of a circle. So the arc down there is highlighted in red. So we would call this arc BA down here, or AB. It can go in any order. So this is what we're going to be working with primarily for this first part of the lesson, and then we're going to switch gears to a different type of angle a little bit later. So for right now, all you need to know is kind of what that central angle looks like, what the arc looks like, and then we're going to talk about how those actually apply here in a little bit. When we talk about arcs, a couple of things you need to recognize. First, there are some vocabulary terms that you need to know. We have a minor arc. So when we talk about arcs, there's three different types. A minor arc has a measure that's less than 180 degrees. So anything smaller than 180 degrees or less than half of the circle. When we look at arc measures, they are going to be the same measure as your central angle. So when we look at the picture down here, we talk about minor arcs, which are named with two letters. That's really important to note. Anytime you're talking about a minor arc, you're going to use just the two letters. Where do you start? Where do you end? So the example that I have there is arc AC. So if we look at the picture, we would have arc AC right here. We go from A directly to C. As far as the measure, like we said, it's the same measure as the angle in the center. So if I told you that angle CBA had a measure of 50 degrees, we would know then that arc AC has a measure of 50 degrees. Okay, so in this particular instance, when we talk minor arcs, they have to be less than 180 total degrees. They're going to be the same measure as their central angle. They're named with two letters: where to start, where to end. So when you see that two-letter name, you go the shortest distance between the 2 points. When we look at the next one, we talk about major arcs. Major arcs are any arc that has a measure greater than 180 degrees. And again, just like the minor arc, the arc measure will be exactly the same as the angle measure that it corresponds to. Now, with this major arc, we have three letters that we use to name it. So in this case, we have where to start, which point we have to pass through, and then where do we finally end up. So it's not as simple as that minor arc: where do we start, where do we stop? We have to give a direction around the circle as we go. So in my example, arc ADC has to start at point A, it has to come around through D, and then around through C there. So when you're looking at that arc, you're going around from A, you have to go through D first, and then you can finally end up around on point C. So I'm going to try that again a little neater. So A, around to D, and then around to C. So where do you start? What do you pass through? Where do you end? Okay. On the last one then, we have what's called a semicircle. And a semicircle is half the circle. So it's going to be exactly 180 degrees. So basically, when we see these semicircles, they're going to be created from what we call a diameter. From what you guys have learned in the past about circles, that diameter goes all the way across the circle right through the center there. So line segment EA here is a diameter, which cuts the circle in half. So any arc that goes around from E to A. So for instance, in our example there, we have the ACE. So starting at A, passing through C, and finishing at E. That would be a semicircle. We're going exactly halfway around the circle, which is 180 degrees. Just like a major arc, it's important to note you have to use 3 letters to name the arc. So it can't just be where do you stop or start and stop. Where do you start? What point do you have to pass through? And then where do you end up? So ACE tells us start at A, pass through C, go to E. And the reason that's important is if we just wrote arc AE, there would be 2 different ways we could go from A to E. We have to know which direction to go. So make sure you use those 3 letters for major arc, for semicircle. Where do you start? What do you have to pass through? And where do you end? Okay. Now with that then, we get to a pretty important concept here with arc measures called the arc addition postulate. Now this is something that's very similar to what we've dealt with in the past with segment addition and angle addition. So it's not like it's a totally new concept here, we're just applying it to a different geometric figure. So if you notice over on the right here, right above the figure, we have this equation. Now what this equation is telling us is in the picture, if I was interested in arc EA, so if I was going from E to A here, and I wanted to know what the measure of that arc was. Well, if we notice, that arc is split up into 2 smaller arcs. So if I want to know what the big overall arc EA is, I need to know what those 2 smaller arcs are. So that's where we're talking about here, arc A or EC and arc CA. These are the 2 arcs that make it up. So once I know what those 2 arc measures are, I can add them together and make the overall arc I was interested to begin with, EA. So that's all that is. As you go around the circle, if you pass through multiple arcs on your way around, you can just add those arcs up as you travel to get the total distance. Okay, so what we're looking at here then are some examples. Now, anytime you're asked to find arc measures or how to find angle measures given an arc, whatever way you're going, one of the things that sometimes helps with this type of problem is getting everything labeled in the picture first. So if you notice, we have this right angle on the left side here, which we know is 90 degrees. We have a 42-degree angle given right here. And so if I want to find these other 2 missing angles, the one that we could find on the bottom here is half the circle, which we just discussed on that last slide, would be 180 degrees. And so all we're missing is this little angle EBC. So if I look at the picture here, if the left side is 90, the right side total must be 90 degrees. So if that's the case, we need to go ahead and take 90 minus 42, and that tells us that this missing angle here has to be 48 degrees. Now, once we know what all the angle measures are, we can use those to find any of the arc measures that they ask us for over on the left. So for instance, if we want to find the measure of arc CA, over on the picture here, we can highlight arc CA, and we want to take that and match it up with its central angle. So arc CA comes back inside here to 42 degrees, which means my arc measure must be 42 degrees. And so there's my answer for the measure of arc CA. Now, being 42 degrees, one other thing they might ask you about is whether it's minor, major, or semicircle. Being less than 180 degrees, this would be a minor arc. Okay. A couple others on here if I wanted the measure of arc CE. So if we go to that one there, So here we want the measure of arc CE. So now we highlight that over in the picture. Arc CE is this arc right here. Well, that corresponds to that 48-degree angle we just found a little bit ago. So arc EC has to be 48 degrees. So there's the answer for my question. Arc CE must be 48, which makes it, again, a minor arc. If we want arc DE in the picture would be this arc right here. And if we take a look, we will follow it back to its central angle, which is 90, which means my arc measure must also be 90 degrees, again, making it a minor arc. Now, as I start to get into some of these other examples here, like coming back up to the top, arc EA. So that was the first one we started talking about when we first got to this slide. Well, EA encompasses both of these two arcs, the yellow and the blue. So when we look at arc EA, we need to put those two arcs together to get our total value. So 48 plus 42 tells us that EA has a measure of 90 degrees, making it a minor arc. On the rest of these here, as we kind of look for like arc CAD, so if we look at arc CAD, we follow the letters. Starting at C, we go through A, and we continue until we reach D. Now, when we look at that, we got to think about the fact that we're going from C around to D. Now, as I go, there were multiple arcs that I hit. So C to A was 42 total degrees. A around to D was another 180. So my arc addition says, add those two pieces together. So arc CAD would be 222 degrees, which makes it a major arc. Okay, so that's kind of what we're dealing with there. So again, just to kind of finish this out real quick, arc DC. So when we look at arc DC here, we go from D, shortest route to C. So we go from D, shortest route to C there. And again, I pass through multiple arcs, so all I got to do is add as I go. 90 plus 48, gives me 138 degrees. Okay, now 138 degrees is still a minor arc because it's less than 180. So we still have to make sure we classify correctly there. And now we're down to our last two here. So arc DFA. If we look at arc DFA here, starting at D, passing through F, and around to A. So this is the arc we're looking at here in purple. Now in this case, we're going from D around to A, which we already marked on the inside here as 180 degrees. This is a semicircle. So DFA is 180 degrees, which makes it a semicircle. And then our last one, CFA. So when we look at CFA here, we start at C, we have to pass through F, and then we continue around the circle until we get to point A. So this is the arc we're looking at now. So when I look at CFA, I could go around the circle and add 48 plus 90 plus 180, and I could get my total that way. Or if I notice, the only piece of the circle I don't want for this arc is this 42 degrees. So I could just take the total distance around the circle, 360 degrees, and subtract out the one little piece I don't want. Both methods will get you your final answer, which in this case should be 318 degrees, which makes this a major arc. Okay, so these are some things that you're going to see on the assignments. They're going to give you a circle. They're going to give you some angles on the inside. You have to either add up the angles as you go around or subtract the angles from a total of some kind. But all you're doing is just finding out where does the central angle, what arc does it go with, and then find those corresponding pieces. Okay. And that pretty much covers our central angles. Those are pretty straightforward. The big thing you want to remember there is the vocabulary. What type of arc is it? Knowing that the arc and angle are the same measure. And that's about all you got to work with there. Now, inscribed angles. So this is the second type of angle that we're working with. With inscribed angles, a couple of things here. We have an angle whose vertex is on the circle now. So it's not at the center. We notice that in the picture here, angle ABC goes from one side of the circle all the way to the other and back. So the vertex B here is on the actual circle itself. Now in this case, inscribed angles are a little bit different than your central angles in that they're not the same size as their arc. So with the central angle, when the center or the vertex was at the center, the arc and the angle had the same measure. In this case, the angle measure is half the arc measure. So the angle is always smaller than the arc it comes or intercepts. So that's what this formula right down here is talking about. The measure of angle B is half as big as the arc that it creates across the circle. So for example, if I told you that angle B had a measure of 40 degrees, well, that's half as big as the entire arc, so the arc must be twice as big, making it 80. Or they might give you that information in reverse order. They might tell you that the arc measure is 100 degrees, and they say find the angle. Well, since the arc is twice the size of the angle, we know then that to get to the angle, we need to cut it in half, making angle B 50 degrees. So the big thing to remember with inscribed angles here is that they're on the circle itself. So the vertex is on the circle, and the angle is half the size of the arc. So that arc is always going to be twice as big. Now, also with inscribed angles, we have a couple of kind of theorems to work with. Within a given circle, if you have two or more inscribed angles, so in here, notice you have this angle ADC, vertex on the circle. And you also have angle ABC, vertex on the circle. Now, if you notice, both of those angles open up to points A and C. So they both open up right here, A to C. So this arc. When that happens, because both angles are opening up to the exact same arc, let's say the arc measure is 70 degrees, well, based on what we talked about on the last slide there, angle D would have to be half as big as 70, so 35 degrees. Angle B would have to be half of its arc, which is 70, so it'd be 35 degrees. So one of the things that happens here is when you have two inscribed angles that open up to the exact same arc, those angles must be congruent. So in this picture, angle D must be congruent to angle angle B. Okay, so when you're looking at a picture, as they get a little more complicated and they start throwing more things at you, that's something to always look for. Do the angles open up to the same arc? If so, those angles must be identical. The other thing that's kind of an important one, it's one that shows up. Now, this is one that you wouldn't have to remember all the time because you can always get there by knowing the arc measures or angle measures from the picture. But if we have a diameter, okay, so if I have a diameter like we're talking about here, A to C, when I take an angle, an inscribed angle, and I intercept that diameter, so here we have angle ABC, every time that happens, because we open up to a diameter, that means we also open up to a semicircle, which a semicircle is always 180 degrees. And since the semicircle is always going to be 180, if we have an angle open up to it, that angle is always going to be 90 or a right angle. And it doesn't matter where that happens in the picture. So even if I drew an angle over here, as long as that angle opens up to A and C, it's going to open up to a semicircle, which makes it a right angle. Or I could maybe do something like A to C over here. Either way, I'm still going to get that right angle no matter what. When you open up to that semicircle, if you open up to those ends of the diameter, that angle you create is always going to be a right angle. So that's something else to kind of keep in mind, make some of the problems in the future a little bit easier. Last thing I want to do is just go through a couple examples, solving for variables, setting up equations and things like that involving these inscribed angles. So in this picture here, we have an inscribed angle, angle Q, vertex is on the circle. And so if we think back to that first slide, this angle on the inside must be half the size of the arc that it intersects. So that means it's going to take two of these angles. So two of my angles to make one of my arcs. Okay, so that means in this equation here, I would distribute the two. You get 4x plus 1, or sorry, 4x plus 2 equals 96. You would subtract the 2, 4x equals 94, and then you would divide by 4, get your final answer there. Okay, now that's not the only way you could do this problem. The fact that you know that the angle is half the size of the outside means that if I take the outside and cut it in half, I can do the same thing. So I can take this 2x plus 1, that's my one angle, would equal half of that outside arc. So half of that 96. So now what I'd be looking at is 2x plus 1 equals 48. And then I can solve from there. Subtract the 1, divide by 2, we get our x value. Both should get you the same answer. So however you want to attack that type of problem, it's entirely up to you. So you either have to take the angle and double it, set it equal to the outside, or cut the outside in half, set it equal to the angle. Either way, you can get to that answer using that inscribed angle. In another example here, this is one where they don't necessarily give us any arc measures, but we don't necessarily need that either. If you notice, our first angle here, angle H, opens up to arc MA. And if we pay close attention here, we can also see that angle T opens up to arc MA. So right now, it doesn't matter what arc MA is. If I want to know what the value of x is, I go back to that second idea that we talked about, and I know that because these angles open up to the exact same thing, these angles must be congruent to each other. So that x must be equal to that 2x minus 3, and then you can go through and solve. So you can subtract the 2x, you get negative x equals negative 3, x would equal positive 3. Okay? So when you're looking at these types of pictures, when they start getting a little more complicated like this, try to kind of focus on, do you have an arc measure to go with the angle? If so, cut it in half or do whatever you need to do there. Or if they are multiple angles that open to the same arc, set them equal and then solve. Last one here is a little more complicated. So this is where we start kind of adding in all kinds of stuff. Okay, so we have all kinds of line segments and stuff passing through the circle. So we just got to kind of take this step by step. And so on these types of problems, it kind of helps to kind of highlight things as you go through the problem so you can kind of see what's going on here. So for instance, the first thing they ask for is the measure of angle U. Well, here's angle U. So if I draw that out or trace it, so I highlight angle U here, notice it opens up to E and to H. That gives me this arc right here. Well, if we notice, EH passes through the center of the circle, which means this arc from E to H is a semicircle, making it 180 total degrees. My angle then must be half of that, which means angle U is a right angle, 90 degrees. Moving on to the next ones then. Okay, and keep in mind that EH is 180 degrees. We're going to be coming back to that idea here in a little bit. So now arc CH. So I want to find the measure of arc CH right here. Now when this happens, when we want to find the arc, we need to find an angle that goes with it. So for instance, I could note that C and H travel back to angle T here. Now that would be great if we knew what angle T was. Since they don't give us that in the picture, we might want to try to avoid that for now. We might need to come back to it later, but for now we're just going to ignore it. Let's see if CH travels back to anything else. So now if we look closer, CH also goes back to E. And so now we're looking at this angle right here. Well, that angle we do know, it's 36 degrees. So if I want to take that and move out to the arc, all I need to do is double it. That angle measure is half as big as the outside, so this outside must be 72 degrees. Okay. Now, the next thing it asks for is arc CE. So now we want to come over to this other side here. We want to find arc CE here. Well, again, we could try to trace it back to different angles. So we could try to trace it back to, for instance, H. But when I look at where it meets up here, I don't know what H is. So that's not really going to help me. CE really doesn't travel back to anything else. So that's the only thing I have there. So in this case, the angle is kind of a lost cause for us. So here's where we got to go back to something we talked about earlier. We said that from E to H, so all the way around from E to H was a semicircle, meaning the entire thing is 180 degrees. Well, I found this blue portion to be 72 just in the last problem. And so now the red portion needs to make up whatever's left from that 180 that we have total. So to find CE, we're just going to take that 180 minus 72, and so that must be 108 degrees. So there might be times where we have to use previous information from the problem to solve because we don't have the angle measure we need. Okay. Then the next thing it asks for, the measure of measure of angle CHE. Well, angle CHE, if we trace the letters, okay, so CHE here, we're looking for this angle right here. Now that opens up to arc CE, which we just found the answer for. Arc CE had a 108-degree measure, so then my angle must be half of that measure. So if I take 108 and divide it by 2, CHE would be 54 degrees. And then the last thing it asks for, arc ET. So on arc ET, if I highlight that in the picture here, okay, I try to trace it back to a common starting point. So in this case, I might notice that ET travels back to point C. Well, if I look at angle C there, I can note that it has a measure of 25 degrees. So if I know what the angle measure is, that's half as big as the arc. So if I double it, that'll take me outside to the arc measure that I want, which in this case would be 50 degrees. Okay, so that pretty much covers everything that you would need to know. If you have any questions on any of this, feel free to go back and look over some of the material. I know I went through some of this stuff pretty quickly. Also, you can ask your teacher, so email your teacher if you have any questions on this, or better yet, show up to the Zoom meetings on Tuesdays from 8:30 to 9:30, meet up with your teacher. They can try to help explain some of the concepts, or if you started the homework, making sure that they can go over the examples with you there. Okay, so if you have questions, contact your teacher, show up to the Zoom meetings, get the help you need to kind of figure out these pieces. All right, with that, I will leave you guys to begin working on your assignments.